Greetings everyone. Today we're going to explore adding and subtracting radicals. Make sure you understand the previous lesson of reducing or simplifying radicals, as you'll need to be comfortable with that to move on. We do have our foldable for this that'll help out, but it's also pretty quick to jot down in your notebook. Alrighty, we're on the Add or Subtract tab if this is the book that you have this year. On the top half of that book, we do have a place for notes. If you're jotting them down in your notebook, let's just identify these few bulleted points. First and foremost, you can only add like radicals, meaning you guys already understand like variables. Quick example here. If I had a 2x plus a 3x, what would I have? You already know it's a 5x. Well, watch this. We can keep the same idea, but let's just change this to 2 radical 2's, 3 radical 2's, so I now have 5 radical 2's. So if I'm saying they're like, that means they need to have the same radicand. So let's identify that. What makes a like radical? A like radical has the same index and the same radicand. Make sure, and this is what I specified at the beginning of the video, that you simplify your radicals first. They might not be like in the beginning, but once you simplify, they might become like radicals. And as I just referenced, make sure that you combine like radicals. You're going to add or subtract the numbers in front, and you keep the like radicands. All right, let's jump straight into our examples. So to start off on this first example, I see that I have radical 3's, so they're like. If I have 4 things and I subtract 2 things, I have 2 things remaining. See how if you take away the idea of a radical and you just call it a thing or an object, it's easier to just label it correctly. Let's try this next one. Technically, there's a 1 out front. If I have 1 of these and I have 5 of these, then I have 6 of these. On example 3, it's a mix. I have 2 of these and I'm subtracting 6 of these. So I have -4 of these. But I also have 1 of these and I'm subtracting 3 of these. So I have -2 of these. So you're not going to be able to combine all of them all the time. You can have a mix. So here I used colors. Maybe you draw multiple lines. Maybe you do symbols, boxes, whatever helps. Let's take a look at the next 3. In example 4, I do not have like radicals. That's because I need to break down the 12. So the 5 stays. Everything else falls down. 12, my perfect square would be 4. My unperfect square is 3. The square root of 4 is 2. The 3 stays. Hey, we just made like radicals. 5 minus 2 gets me 3 of them. See how that works? Let's take a look at the next one. I need to break apart this 28, and there's a 2 out front. I'm going to show everything carried down every time, just so you can make sure not to lose anything. 28. 28 breaks down to 4 and 7. Square root of 4 is 2. Now, there was already a 2 out front. Don't forget about that. When things are next to each other, that implies multiplication. So I actually have 4 square root of 7. There we go. Now I have like simplified radicals. If I have 4 of these and 4 of these, I now have 8 of these. Example 6. We have to take care of both of them. I'm going to kind of treat it like separate problems for a moment. The 5 hangs out, the 12 breaks down. The -3, 27 breaks down. Square root of 12 breaks down to 4 and 3. Square root of 27 breaks down to 9 and 3. Square root of 4 is 2, not square root of 2, just 2, and that looks weird. It shouldn't be 52, it should be 5 times 2. Square root of 9 is 3, and that looks weird, so we put a dot. It implies multiplication. 5 times 2 is 10. 3 times 3 is 9. There we go. I've got my like radicals. If I have 10 of them and I subtract 9 of them, I have 1 of them. And I would accept with the 1 or without. A couple more examples. Example 7. Let's take a look. I have a lot of breaking down to do. So 54 is going to break down. 24 is going to break down. And 96 is going to break down. I feel like there should be a number there, so I'm going to put a 1. 54. Remember, you need the largest perfect square that divides in. And in this case, that's going to be a 9. 54 divided by 9 is 6. Let's look at 24. 24, the largest perfect square that fits in is 4, 6 times. And 96, 96 is big, so I probably have a larger one. And believe it or not, the largest perfect square that fits in is 16, and it fits in 6 times. All right, let's reduce those radicals. Square root of 9 is 3, so remember we're going to be multiplying. Square root of 4 is 2. Remember, we're going to be multiplying. And square root of 16 is 4. And remember, we'll be multiplying. 2 times 3 is 6. Positive 3 times 2 is positive 6. And negative 1 times 4 is negative 4. Alrighty, we have 3 like terms. Oops, sorry, I don't know why I put a 3 there. Did you catch my error? That should be a 6. All right, let's combine like radicals. 6 plus 6 is 12. 12 minus 4 is 8. I have 8 radical 6s. Let's look at example 8. I have 2 radicals to reduce. So the first one stays. Radical 20. Radical 20 breaks down to 4 and 5. And then we also have radical 8, which breaks down to 4 and 2. All right, the first one stays. I like to drop them down so I don't forget. 3 times 2, and maybe you take care of it right away, but I'm going to write it out. And negative 3 times 2. All right, the first one stays. 3 times 2 is 6. Now, could you write less work here? A little bit, yeah. I want to see that first step for sure. Now, on this one, I can only combine 2 of them, right? Negative 3 subtract 6 is a negative 9 radical 2s. And I didn't use the radical 5, so it just hangs out. Positive 6. Radical 5. And I would be okay if that's flipped. The order in which you write those 2 radicals does not matter. Our last example. All right, I'm going to do this all in one color. So I'm assuming since you're not using multiple colors, let's see what this looks like. The 45 breaks apart, the 5 stays, the 20 breaks apart, and the 6 stays. 6 does not reduce because there's not a perfect square that divides in. 45 breaks down to 9 and 5. 20 breaks down to 4 and 5. Square root of 9 is 3. This one stays. Square root of 4 is 2. And this one stays. Let's see what we can combine. I've got 5, 5, 5. I can combine those 3. Negative 3 plus 2 is negative 1. Negative 1 minus 2 is negative 3 radical 5s. I didn't use the last one, so it just hangs out next to it. And again, you could reverse this. You could say negative 2 radical 6 minus 3 radical 5. Alrighty, that's our lesson on just adding or subtracting radicals. If you need other operations, please see my YouTube playlist. You can just search on my YouTube channel if you need. I have videos that go over the multiplying, reducing, etc. Oops, I don't know why I wrote playing. That should say playlist. Also, as always, make sure to check out Google Classroom to see what your task is. Make sure you've got it turned in. Let me know what questions you have, and until next time, have a good one.